So we're going to be doing server-side template injection, also known as SSTI. So basically we're going to cover some of the more basic kinds of SSTI out there, and going over everything like that today. So if you're unfamiliar with this exploit, it's basically an exploit that targets the templating engine. Oftentimes in websites, developers will implement templating to help their dynamic websites. Like here in this example from TryHackMe, you see like it'll just echo out the profile. So they say welcome to the profile. So obviously, as a high level, this isn't going to really be vulnerable, but when you allow user input, we can actually use it because templating can be used to execute code. So obviously that's pretty bad. So actually something I'm going to pull up right away is Payload All the Things has one of the best repositories for server-side templating injection. So let's start there. And where we want to start is in the methodology. So normally what you're going to want to do is you're going to have to check to see what kind of templating engine is running in the background, especially if it's a black box kind of test. So normally this is the basic methodology. This doesn't cover every kind of templating, as we'll see in a little later. But normally you want to start here, and the idea is we're going to try and execute 7 times 7. And if we get a response of 49, obviously 7 times 7 is being executed. But if we don't get that response, that means the code isn't being executed, it's just being echoed back, right? Like if I just did like 7 times 7 here, it's just going to echo back 7, well, 7 asterisk 7. So we want a way to generate this to be 49. So in templating engines, they all use kind of different things. As you can see here, like we have a $ curly bracket to like say, oh, this is a template, execute this. And the reason why templating engines do this is they can often have like custom controls. So you can like put in like, you can basically store essentially a variable, and like this, instead of like 7 times 7, developers will store like a variable, and it'll be like whatever, echo username will be the variable, and it'll execute code. And so very useful for developers, but obviously we can use it for our own malicious intent. So this is a good starting point, definitely. So we're going to start with this $77, and we'll see, we're looking to see if it will return us 49. And so that one doesn't. So we're going to follow the red arrow, right, if it's a failure. So we're going to do 7 times 7 now with a double bracket. And it does return us 49, which basically shows us that this is vulnerable to SSTI, as well as normally when you see these double brackets, it's going to be Jinja is the templating engine, or Twig, which are really the more popular ones out there running on like a Python platform. So we're going to start with Jinja. And like as we see, we can try something like this as well, just to see exactly what we have. And we see that we do get the long results of, what is that, 7 sevens. So you can read this more in depth, but basically it's just going to be a templating engine for Python. And they have a whole bunch of different exploits available here, but we're going to do it step by step instead of using a pre-built one. So the first thing you're going to want to do for SSTI is we're going to want to identify for SSTI with Ninja or Twig is you're going to want to start with the class variable, right? So we're going to be using something called MRO. And if you're unfamiliar with MRO, it stands for method resolution order. And it's basically we're going to inherit classes, and we're going to step up the Python tree to basically be able to execute subclasses, which are pre-built in classes in Python, where we can where we will be able to basically execute system commands. So I guess I can like demonstrate this. Might help make it some more sense. So if I just do like a Python 3 interpreter, I can just call the class variable. If I can type, and we get return the class of string. So then we're going to use MRO to help us step up, to basically help us step up to the object variable. And so with the object variable, we can like call subclasses, and then we can have access to a lot of pretty much useful things. So we want to call one, right? Because we're going to call, you start from 0 encoding, right? So 0 would be str, 1 is object. So you see, if I do the 1 for MRO, I'm calling the first or the second one. And then in there, we can call we can call for subclasses. Subclasses. I think I need this at the end. There we go. And I get listed out all the different subclasses available. So you remember how earlier I was like, oh, there's pre-built, like developers might want to do like user name or whatever in there. Python has a bunch of pre-built ones, and you can see them all here. So what we're going to do is we're going to do that on the website, right? So we'll do the exact same thing. We start with class, because now we're basically doing a Python interpreter, and class string. So then we can do MRO, and we see the exact same thing. So we're going to want to do 1, and then we can make sure we correctly identify it. And then we're going to want to list out all subclasses.
Why the 1?
Because when you see if we do no one, there's 2. So we're going to have to tell it, oh, we want the object class, right? Otherwise, it's not going to know. If we just do dot subclasses, it's going to be like, well, where are you getting subclasses from? You haven't selected either of these, right? So we start with classes, then we're
Roger.
moving to MRO, and then we have to say of the MRO classes, we want object.
Copy.
Does that make sense?
Yeah, yeah.
Okay, so now we have a list of all these classes that are available to us. Gonna open, oops. Gonna open VS Code to help us. Oops. Let's get rid of that quickly. Okay, so now we have all these classes available to us. And there's only one that we really care about, which is, oh, it's actually right here, is popen. And so with popen, it's basically going to allow us to execute commands. If we, no, we're in Ninja, popen. Here we go. Exploit SSTI with subclass. So this is under the Ninja remote code execution. So what we want to do is we're climbing up the MRO subclasses to find popen, and then we can execute commands with it. And then sometimes, not always, you're going to need the shell equals true, standard out -1, and communicate 0 with a strip. You can throw it in there. It'll sometimes need it, sometimes won't. I'm not really sure what changes in the code of why you need it sometimes. But first thing we have to do is, similar to MRO, we have to locate where popen is, right? Because we can't do like subclasses and we can't do popen in here. That's not going to work. What we need to do is we need to do it the same way with MRO and call it. So like you could do 0 whatever, or I think I'm doing this backwards. I think we call it out here. You call it out there, right? So we're going to want to know where popen is. So if we go back to where I called all the subclasses, very easy ways, you just put them here, and then we do find, and we're going to replace commas, because if you see here, they're separated by commas, and we're just going to replace them with an enter. And then we don't need the top line, and then we just search for popen, and we see it's on line 401. So with that, all we have to do is just call the subclasses to line 401, and we get access to popen. So then what we do is we can just take the rest of this, which is just with popen, then we're going to call the popen class, which basically just allows us to execute commands, and just we're going to execute commands arbitrarily on here like this. And instead of cat flag.text, since we don't have that, we'll do like ls. And then we're able to execute commands. So does anyone have any questions about how we did that through Ninja with MRO?
No, that's pretty sweet. What was the trick to format all that in VSC?
So I'll just go back. I did Control F
Uh-huh.
to open this, and then it'll open it like this. And I just did a comma because they'll be separated by commas.
Okay.
And then I just did Shift Enter. Or you could turn on, I think this is regex. You turn on regex, I forget if you need to do it through a setting. /n, no, /n won't work. You'd have to turn on, oh no, this is regex. I'm not sure if regex will work for the bottom one. Let me test. No, it won't. So you have to do Shift Enter to separate them, but no, I did \n. So Shift Enter, and then it'll list them all out, so that way we can easily and quickly identify. And
Thank you.
sometimes it'll be a little hard to tell. Like maybe there's a couple lines up here, maybe you're not, sometimes it won't communicate properly, so we can always check, right? So say I forgot to delete the top line and I see 402. I can just go to here and do like 402, and it'll tell me what it is. And I see it's dangerous JSON, compact JSON. I'm like, that's not what I want. I want popen. I'll just go here, although, oh, it's one above, right? So instead of 402, I'll just subtract 1 and go to 401.
Gotcha. Thank you. That's a neat tip there.
Yeah, it makes it a lot easier. Because sometimes you might end up like pretty far down. Like, what if we get like Wurzburg local? It's just easier. That way you don't have to keep testing out random numbers. You can just count backwards or forwards. So that's pretty much the basics of server-side template injection through like a Ninja Twig Python interpreter. If no one has any other questions about that, I'm going to move on to Portswigger, which basically will have a few different ones because there's multiple languages out there, essentially. So where this chart starts to fall off is when we get to, I guess more obscure would be one way to say it, things. So we can go like to this, right? And if we start clicking around, like home or whatever, maybe view this one, we get product ID equals 2. We could test that, but it seems unlikely. That'd be more like a LFI or like SQL. If we click here, we get a message equals, unfortunately, this product is out of stock. So that's pretty unusual to see in the header. So what we could do is just do like a 7 times 7, right? Because we want to follow this chart. And we see 7 times 7 doesn't work. So then we want to try we see $77 doesn't work. So then we want to try the double. So if we do the double, we see that it also doesn't work. So now you might be like, oh, well, I tried the two things. It's not vulnerable. Well, you're going to have to try more things, right? Because right here we have Ruby. And if we test the Ruby payload, we see that it does get processed and runs as 49. So it's a good starting point, I guess someone saying is the chart. This chart's super popular. You see it on pretty much every website that talks about SSTI, but it does not even come close to showing the full story, right? Because if we did the 2 payloads instead, and it said not vulnerable. So don't take that to heart. I don't know if they're just trying to say it's for Ninja or just these ones, but you're going to need to test more payloads than just those 2. So anyways, for this challenge, we found that it is Ruby. And so our challenge basically was to delete the same thing all Portswigger is just delete the file called morale.txt on Carlos in Carlos home directory. So this is a basic one. So basically there's just a system using the ERB engine. So we just call system to execute commands. So we could test with like cat etc pass wd, and we see it gets returned true. So we can just we can just do rm home carlos morale.txt to complete the challenge, since that's what they wanted us to do. So that's just like the basic Ruby one. Now we'll go to their other ones, which are a bit more fun, but it also shows just like how diverse SSTI is. This one is probably the most popular one you'll see, at least in like CTFs, but it's not going to be the only one out there, right? Like payload all the things alone has just so many different kinds of payloads. There's JavaScript, Java, Ruby, Python. So you're going to want to know more than just how to do an MRO subclass one. So we did the first one. Now we'll do the next one, which, let's see here. Let's log in. So they gave us credentials of Wiener Peter. So we'll log in quickly with that. And we see here that we have two things. Let me start up burp. We have a place to update our email address and a place to choose our preferred name. So once burp is done, once we get burp, I'll do that in a minute, started, we will intercept these requests and basically see what's happening. So whenever it's done, okay, so we'll start with like email. We'll do like new@new.com, and let's see what happens when we intercept that request. Pretty simple, just putting in a post request. And I mean, you can test this for different things, but you're not going to find anything there, so we'll just forward that along. Is that all of them? Okay, and then we also have preferred name, so we'll do the same thing and we'll capture this. And we see here that there's a blog, post, author, display name, username. So something we can try is doing like the 7x7 in here and forwarding it along till it is done. I guess we got 3 forwards. And let's turn intercept off for a second. We want to find our display name, so I'm gonna go here and find a way to display our name. So if we view a post and we go to like leave a comment, and I'll leave a comment, and then we try and view the post, we get an error message. So error messages are always very helpful because we can find maybe what's running on the back end and maybe if we broke something. So here we find that Tornado is running on the back end under Python 2 dist Tornado. So if we go and research Tornado templating engine, we find that it is a templating engine, right? So if we put something else there, like maybe single quotes or some other characters that broke it, and we just Google Tornado Python 2, we'd find it as a templating engine, and then we'd probably want to test for different sorry, I lost my train of thought. If we found it was Tornado running Python 2.7, that would probably indicate that it is going to be vulnerable to SSTI if you had no idea what exactly you should even be looking for. Like if this wasn't a challenge, it was just a straight black box test, it'd be a pretty good indicator that this may be vulnerable to SSTI. So the first thing we want to do is we want to find how Tornado actually works. So let's just do like tornado templating examples. And if we can find a good guide, it'll basically just tell us, here we go. So this is like their main site. And if we look around, we'll find that essentially it's called through, maybe it's not on this page. We're basically going to find that it's called through here. Expressions are surrounded by double squirrely brackets, like item 0. So what we know now is if we go back to this link and we get, I guess we just go to history. Be easier if I just threw it through history into repeater. Let's see here. Here we go. Let's put that in repeater. So it's basically saying that this is how it's being called, is through the squirrely brackets. And then when we try and do something else in there, it breaks it. So how this is being called, most likely, what we can interpret is it's going to be called like this. So we can't put an expression inside of an expression. So what we're going to need to do is we're going to need to close this on our own. So we're going to need to close it before we open a new one. So to do that, we're going to have to close it first. So if I go back to burp, and then I close it, and then I do a test payload of 7 times 7, and send that off. I don't think I'll have to follow redirection. Guess we'll find out in a minute. When we go back here, we see that the page loaded, and we see that I was able to escape and execute the 49. So then what I want to do is, okay, we can read documentation and figure out how to basically execute code. So we know it's running Python, right? So if we see right here, we see that it says control statements are surrounded by squarely percent, and then it shows an if. So basically we can execute Python code like that. So that's how important it is to read the documentation, but you can just also look up tornado SSTI, and people have already demonstrated out there how to do it. Where's a good one? We just see what Hacktricks has for us. Let's go to tornado. Ooh, slow. See it on the side. Tornado. And we see here that all we have to do is just, it is like we said, and then we're just importing OS, and then we're doing an os.system. Because this is just, I don't know what happened. Because this is just executing Python code, essentially, right? Like if we just went to, I mean, I'll have to get rid of all this stuff, but like this is just Python code right here, right? Import os, os.system, who am I? That's just executing Python code. So if we do that in burp, and we just try to execute Python code, and send that, and we go to wherever the blog post is. No errors, which is good. And if we scroll down, we see we are Carlos. So we were successfully able to execute commands. So we have RCE, and all we have to do now is, same as last time, remove home Carlos morale.txt, send it again, and then we've completed this challenge. So for this one, you had to first find through burp, or I guess you could also use zap, something that looked like it, and then just start testing around until you were able to produce errors. And then with those errors, you're able to find what was running on the back end, and then you could execute commands. Anyone have any questions about that one?
You're my hero.
I do have a question.
Yeah.
How reliable is SSTI in the real world? Like, is it a really common vulnerability?
I think it's fallen off a lot in the last few years. I haven't looked up any data. I've heard people talk about how much it's fallen off because it's, don't let users have control over those variables. So it's kind of like SQL injections where it's fallen off, but definitely something you'll always want to check, especially in parameters that developers might not think users have access to. Something like this one in burp, right? Like they're not going to think, oh, they'll capture it in burp and look for it here, but definitely less common than it probably once was.
All right, thanks.
All right, so we're gonna do two more off of Portswigger. We're gonna do the next two. Um, Let me see here. Oh, I'm gonna open this new tab because I'll have to save those credentials. Don't need that anymore, and we figured out tornado. So, new box, we're gonna have to go to my account and log into content manager, and I copied the password. And if we go to like the home page and we click on a post, we see we are like the content manager of the site, and we have the ability to like edit templates. And so in these templates, looking at them, we see that there are like pre-built commands in the $ with the brackets, which kind of indicates that this may be vulnerable to SSTI. If it was like a good developer, they'd like whitelist and be like, only product.stock and product.name and product.price is allowed, but we'll want to test and see what happens if we do like a 7x7 to see if there's like whitelisted. We'll have to wrap this. Maybe I'll have to wrap this. Not sure if that will matter, but doing it just in case. And we're gonna see basically 49 is executed, so there isn't like whitelisting going on. So we can start throwing in payloads, but we have really no idea what's running on the back end. So kind of like last time, we're gonna just like throw in something that probably won't exist and send it off and see if we can produce errors on the website. So now we get errors, and here I find that it's FreeMarker with the Java. So we've confirmed we have server-side template injection, and we know it's FreeMarker. So all I have to do is just do FreeMarker server-side template injection and send that off. And if we look here, hack tricks. Oh, you know what? I think it's actually on payload all the things. It is. FreeMarker's here. There's pre-built things for FreeMarker, and we just got to find the one that's matching our templating option, which is this bottom one with the $. So what are we executing? ID. So we can just scroll to the bottom, edit template, and try to execute ID to see if we can execute commands using the pre-built one. And we see we can execute ID. So we do have RCE. And like last time, we just have to remove the file, home carlos.txt, to complete it. And that completed it. So again, super similar to last time, only this time we were like an content manager admin of the site, so you'd have to get like auth bypass. And then once you have auth bypass, you can pop a shell pretty easily. Okay, so now we're going to do the last one. Well, there's a few others, but it's the last one we're going to do for Portswigger, which is going to be look for known exploits. So it's not going to be that much different than the... Do I need any special things? No. So it's not going to be that much different than any of the ones we haven't done before. It's the same idea. We're just really reinforcing the same idea of just there's a ton of different templating out there. And even though this chart is nice, it's definitely not something you want to live by, because just testing these won't always work. So if we click view details, we see it's got the same strange error message. So we can start testing for like SSTI in here, 7 times 7, and see what we can get. That doesn't work. Try like doubles, and we get an error. So again, we're going to read this user local libnode, and we see it's running handlebars. So we can just look up like handlebars, and we can read documentation, but the name of this one was just with a documented exploit, so I just looked up like handlebars exploit. And there's a bunch out there, but I believe Hacker Tricks has a good one. Handlebar. Oops, press enter one too many times. And you see here that there's a pre-built exploit. And it's just basically, okay, Hacktrix is running very slow for me. It's just executing, okay, it's just basically executing who am I. Can I just copy this? Just executing who am I. So we can just copy like the URL encoded version, since we are passing it through a URL. And paste it. And it's a very strange output. I didn't look much into this, but that's what we had to do to solve the lab. But again, it's the same as last time, is we're going to want to figure out what kind of templating engine is running on the background, because they're all different, right? So you're going to want to somehow find out what's running on the background, either find third-party application through like enumeration, or you're going to have to produce errors to see what exactly is running on the background. So does anyone have any questions about what we have done?